Hi, and welcome to this series on Clumsy Computer where we look at functional programming and try to understand it better and why we'd want to use it and what the heck it is. And actually, this is what this first episode is going to be, what the heck it is. So let's just have a look at what functional programming really is. Now, the thing with functional programming is, if you look it up online, there's going to be a lot of definitions, a lot of information, a lot of very technical stuff that's going to describe what it is. But I don't think I'm even going to simplify that. I think it's still basically the same thing, but I'm just going to try to talk about it in a way that's very simple. And basically, the only thing for me that a piece of code has to have in order to be able to be described as functional is that it has no shared state. Now, you're probably confused about that, and that's fine. Let's look at what I mean. If you imagine, for example, some code, and you have a function, right? And that your function just takes some stuff, it takes x and y, and then it does some things with x and y in here, and then it returns a result. Now, for this to be functional, what I mean by no shared state is that this function, whatever it does in here, is only going to depend on x and y. So it only takes in some stuff in the arguments, and then it spits out some other stuff, and that's all that the function does. When you have a function like this, you can call it, and then this is another term that people use to describe functional code, you can call it a pure function, and you might hear this term. For me, this is included in no shared state because this function does not have a shared state. So what would the shared state be? A shared state would be if up here you say, data equals some kind of object, and then in here you're using data, but you can't do that. If you do that, it's not functional. Why is that? Well, that's because then there is a shared state to your code. So your function then is accessing and using something that's outside of it. And the reason why that's, you might say, bad, or is maybe not as clear, is because you might have a different function or a different piece of code somewhere else that accesses data as well and maybe changes it. And so then the point is that when you are inside this function, if it depends on something from the outside world, then it's really difficult to reason about what it does, because it can depend on any number of things, any kind of external data. But if it's a pure function, it only depends on the arguments that you give it. And more than that, it also can't do stuff to the outside world. So it can't then say, it can't even say file.write, technically speaking. We'll look later at ways to get around that, but it can't even really say file.write. The reason for that is that then it would have side effects. So this is another term, no side effects. This is something people use to describe functional code, as it doesn't have side effects. For me, both of these are kind of go into this no shared state here. So I think that is clear enough to describe everything. The reason you can't do that is that, again, then it's difficult to reason about your code. So it's not 100% always clear what this function does, because, for example, writing to a file might fail, or the file might already exist, or something like that. Or reading a file, all those things. So this is basically what functional code is. And we're going to look in a second at why you would want to write code like that. Now, more than that, there are a couple of more things that are not, strictly speaking, required for your code to be functional, but that you will very frequently see when you are dealing with functional code and when you're trying to write functional code. And these are two things that actually are very useful. And I'm going to show you why using these things can help your code be a lot clearer. It can make your life a lot easier, because when you use these techniques, you have a lot fewer headaches when it comes to reasoning about your code, looking where everything is and how to structure everything. Things become a lot easier for you. And generally, I I don't necessarily want to say you'll necessarily have fewer bugs in your code, but it will be easier to track down your bugs and what's happening, and to reduce all that kind of confusion and to reduce complexity in general. So these two other things are, first of all, immutability. So immutability means that rather than modifying something that already exists, rather than modifying an object, like changing data around, when you interact with objects, you make a copy of that object and you use sort of a different version of that object. So an example of this would be when I want to change something about an object, instead of going into that original object and changing it and then using that same thing, you just create a new object that has the new stuff that you need. And this is really ties back to this whole thing about no shared state that we saw earlier, because it's kind of the same thing. Basically, there's not like one kind of object that's constantly being changed from a bunch of different places and you have to keep track of the changes. There's just something new every time. The second kind of extra thing is using functional tools. And actually, these tools are map, reduce, filter. You may have heard of these, and there's a few other ones that you may have seen. These are tools that, if you use them, it will make your code a lot easier to read. It'll make everything a lot simpler. You're going to have to write less code and it'll be a lot more clear. And we're going to go into what those things do, don't worry. And actually, there's another point, because when you're using those functional tools, you're doing something else that is typically done in functional programming. You're using first-class functions, or sorry, not first-class functions. You're passing functions as values. So that means what you have is higher order functions, and it actually means that functions are first-class objects in your language, so you can pass them around just like you pass anything else around. And what higher order functions are functions that like take and use functions as arguments. Just x and y can be a function just as well as they can be anything else. Let's have a look at what your code would look like if you use this kind of approach. So actually, let's first look at what your code would look like if you didn't. So let's just say you had, for example, a kind of we have a kind of list of pets, and our pets are objects, and these objects can have maybe the name of the pet, and it's going to be Bobby, and the age is going to be 23. We'll just store their ages. And the second name is going to be Cindy, and Cindy is going to be, well, actually that's pretty old. Let's make Cindy 10. And then Joe is going to be 5 years old. And let's say that you want to write some code that it takes out the ages, is what it does, and then it doubles the ages, let's say. So how would you do this in kind of a boring imperative way? Well, you would say for let I equals 0, I less than pets dot length, increase I. Then what you want to do is pets of I is going to be pets of I dot age, for example. And then if you'd like to, let's do this in 2 separate steps, and I'll show you why that is in a second. And if, for example, then you'd like to double those ages, you're just going to say pets dot I times 2. Well, what's happening here? Let me just illustrate this by making these into functions. So we're just going to say function get ages and function double ages. And you can see that if I were to say get ages and double ages, and then I console log my pets, and if I then run this code, you will see that I get an error because I accidentally put a colon in there. You will see that I do get indeed the result that I expected. I get 46, 20, and 10. So this code works, which is great. But the problem with this code is we violated what we talked about earlier, right? So we do have a shared state. It's this pets variable. And And the thing is, more than that, our functions have side effects because we are changing this pets array. And, our functions aren't pure at all. And so this is something that's not functional. And we'll talk later about, how we can make this clear. A way to make this better would be to pass this pets array in here, and then we can change it and return it. But you can see that we're still really modifying it. This would improve the situation a little bit. This would improve the situation a little bit, right? So it still gives us the same result. And so technically speaking, our functions don't have side effects now, and also they don't have a shared state. This is, strictly speaking, it is indeed functional, but this can still be improved. And I'm going to leave it here for now. And in the next video, I'm going to show you how you can change this entire code into something that looks rather more like this. Pets dot map double, get age dot map double. And this is going to really be, well, we're going to have a couple of extra lines of code, but this is basically going to be most of our code reduced to this one line. And so that's going to be really great. So if you're interested in that, in the next episode, we're going to look at map.